Picture this. Billions of years ago, our solar system was just a baby, a swirling cloud of gas and dust. We call this a solar nebula. It was chaotic, energetic, and full of potential. At the center of this cosmic dance floor, a star ignited. Our very own sun burst to life. The solar nebula was a crowded place. Planetesimals were constantly zipping around, pulled this way and that by gravity. Sometimes they collided. The small ones were absorbed, becoming part of something bigger. These collisions released incredible energy, heating up the young planet. Over time, one particular planetesimal, destined to become Mars, began to dominate its region of space. It pulled in more and more planetesimals, growing larger and larger. Imagine the early solar system as a giant cosmic construction site. Everywhere you look, there's action. Planetesimals, some just rocky boulders, others glowing with the heat of their formation, are constantly colliding. It's a chaotic, almost violent process, but this is how planets are built. And in one corner of this cosmic construction site, Mars is coming together. As Mars grows from this constant bombardment, its interior becomes a crucible of intense heat and pressure. This isn't just surface heat, it's coming from the planet's very core. Remember those radioactive elements? Well, they're like tiny space heaters, constantly releasing energy as they decay. This, combined with the heat from the impacts, creates a planet-sized furnace. Millions of years pass. The bombardment of planetesimals slows down, giving Mars a chance to breathe, to cool. The outer layer of molten rock, exposed to the coldness of space, begins to solidify. This is the birth of Mars' crust, the solid ground on which its future will be written. But the cooling process is far from peaceful. Imagine standing on the surface of early Mars. The ground beneath your feet vibrates with a low rumble, a constant reminder of the incredible forces at work deep inside the planet. The air is thick with the smell of sulfur, and the sky glows with an eerie reddish light. Look up and you'll witness a spectacle unlike anything on Earth today. Among these volcanic giants, one mountain stands as a testament to Mars' fiery past: Olympus Mons. Even today, billions of years later, it remains the largest volcano in our solar system, a towering monument to a time when Mars burned with an inner fire. Imagine a mountain so large that its base would cover the entire state of Missouri. That's Olympus Mons, a shield volcano that dwarfs Mount Everest by a factor of 3. But amidst this fiery inferno, whispers of a different future for Mars were beginning to emerge. Volcanic eruptions, as destructive as they seem, were also releasing something crucial into the Martian atmosphere: water vapor. Along with gases like carbon dioxide and nitrogen, water vapor began to accumulate, forming a thick blanket around the cooling planet. This early Martian atmosphere, denser and warmer than it is today, held the promise of a very different Mars. For a brief, glorious time, Mars might have looked surprisingly familiar. Forget the dusty red planet we know today. Picture instead a world with clear blue skies, white fluffy clouds, and bodies of liquid water spread across its surface. This was Mars in its youth, a planet where water, the essential ingredient for life as we know it, flowed freely. Imagine standing on the banks of a Martian river. The air is warm and humid, heavy with the scent of unfamiliar plants. The sound of rushing water fills your ears as the river, carrying sediment from the highlands, carves its way towards a distant sea. This isn't just water flowing, it's the lifeblood of early Mars, carrying nutrients and shaping the environment in ways we're only beginning to understand. But this period of Martian history, this time of blue skies and flowing water, wasn't destined to last. Unlike Earth, Mars lacked a strong magnetic field, that invisible shield that protects our planet from the constant bombardment of the solar wind. The solar wind, a stream of charged particles from the sun, slammed into the Martian atmosphere, slowly stripping it away, molecule by molecule, into space. Without its protective shield, Mars was losing its lifeblood, its atmosphere, and with it, its chance to hold on to liquid water. The transformation of Mars from a potentially habitable world to the cold, arid desert we see today was a slow, drawn-out affair. Imagine watching a vibrant blue marble, streaked with white clouds and dotted with oceans, gradually fade to a dull, rusty red over millions of years. That's what happened to Mars as its atmosphere thinned and its grip on liquid water weakened. Today, when we look at Mars through the eyes of our robotic explorers, we see a world frozen in time, a stark reminder of the forces that can shape planetary destinies. Gone are the rivers and lakes, the clouds and rain. In their place we find a desolate landscape, painted in shades of red and ochre where silence reigns supreme. The only movement comes from the occasional dust devil, swirling across the plains, or the seasonal growth and retreat of the polar ice caps. Even in its present state, Mars bears the scars of its lost past. One look at Valles Marineris, the grandest canyon system in our solar system, tells a tale of ancient tectonic forces and perhaps even the erosive power of long-vanished rivers. This immense chasm, dwarfing the Grand Canyon, stretches across the Martian surface, a testament to the planet's once dynamic geology. Our fascination with Mars isn't new. For centuries, humans have gazed up at this red point of light in the night sky, wondering about its secrets, but it wasn't just gazing. We wanted to get closer, to touch it, to understand it. But flybys were just the beginning. We wanted to land on Mars, to touch its surface, to taste its thin atmosphere. And in 1976, the Viking landers did just that, becoming the first spacecraft to successfully touch down on Martian soil. Imagine the anticipation, the excitement as these robotic explorers sent back the first images from the surface of another planet. The evidence gathered by these rovers painted a clear picture. Mars wasn't always the dry, desolate world we see today. They found evidence of ancient rivers and lakes, minerals that form only in the presence of water, and even signs of past hydrothermal activity, those hot springs that could have provided energy for early life. It was like piecing together a jigsaw puzzle, each discovery bringing us closer to understanding the planet's watery past and its potential to support life. But our robotic explorers are just the vanguard. There's a growing sense of inevitability that humans will one day walk on Mars. It's no longer a question of if, but when. The dream of sending humans to Mars has gone from science fiction to a tangible goal, with space agencies and private companies alike setting their sights on the red planet. Mars, once a symbol of our celestial neighbor, is becoming increasingly familiar, a world we're actively exploring and planning to inhabit. The journey ahead will be long and arduous, but the destination is too compelling to resist. As we stand on the cusp of this next giant leap, one thing is certain: Mars awaits. And when we finally arrive, it will be the culmination of centuries of dreams, a testament to the human spirit of exploration, and perhaps the beginning of a new chapter in the story of life itself.